This is Mr. Hanna. Welcome to What the Format. Today we're going to talk about transformations as they apply to linear functions. Now, I'm not a big fan of transformation of linear functions. And the reason why is because when you do transformations of linear functions to the actual function rule, it can be simplified. So the transformations actually kind of get lost when you simplify. So what they've done to keep that from happening is they use function notation. Okay, so all of the transformations of linear functions involve the f of x, the original f of x. Now, of course, this doesn't have to be f. They could change this, but usually they stick with f as your first function. So your transformations then would be other function designations, g, h, m, and p. Okay, now I had a video on the transformations before. It looked like this. Okay, recall that the plus k was your vertical translation or shift. Inside here, the minus h was your horizontal translation or shift. Now, recall that a plus k takes you up and a minus k takes you down. With a horizontal, a minus h takes you to the right and a plus h takes you to the left. It's backwards on the inside. You need to memorize that. A lot of students get that backwards and it really messes you up, especially on multiple choice, because they'll oftentimes have the right option in there, even if it's going left or vice versa. Then out front, you have your A. Now, if the absolute value of A is greater than 1, it's a vertical stretch. If the absolute value of A is less than 1, it's a vertical shrink. Now, I don't like dealing with absolute value on here because it kind of messes things up. So what I've done is I've separated the minus and the A. So I look at the A without the negative. If the A is bigger than 1, it's a vertical stretch. If it's less than 1, it's a vertical shrink. So let's say I have minus 3. I ignore the minus and I look at the 3. 3 is bigger than 1, so it's a vertical stretch. Okay, now if I have a minus 4/3, again, I ignore the minus. 4/3 is bigger than 1, so it's a vertical stretch. So just because it's a fraction, okay, doesn't mean it won't be a stretch. Just look at the A value. It's either bigger than 1 or it's less than 1. Then if there's a negative there, that's your x-axis reflection. If the negative isn't there, like it's positive 2, no x-axis reflection. Okay, and I try to separate those out. So to me, that's your 4 basic transformations. Okay, now there are 2 others, but they're a lot more complicated and they mess things up a lot. Usually when they have the other 2, the horizontal stretch or shrink or the reflection across the y-axis, I usually resort to xy tables to graph the function. They want you to sometimes describe the transformations, but I found a lot of times they don't teach that right or even do it right. So I just try to avoid those at the beginning so as to not get confused. But here's some examples. So if f of x equals x is my baseline, my first example, g of x equals 3 f of x. So I look, where is this? The 3 is in front. Okay, if it's in front, it's a stretch or shrink or maybe an x-axis reflection. Well, 3 is positive, so no reflection. 3 is greater than 1, so it's a vertical stretch by 3. That's what I would put. Okay, now if you're graphing this, what you do is this 3 times the original slope becomes your new slope. So you'd still have your original y-intercept, which in this case is 0, 0, but now your slope is 3. So instead of going up 1 over 1, like this does, now you've multiplied it by 3, so you're going to go up 3 and over 1. Okay, remember, why the over 1? Because anytime you have an integer as a slope, 1 is your denominator. That's your run. So you rise 3, run 1, it's in the positive direction, you're good to go. Now here, this is inside. Notice it's inside, so that's a horizontal translation. Well, negative 2 is really right 2. And that's how you would describe it, right 2. Okay? Then you have right here, m of x, f of x plus 4. Notice where the plus 4 is. That's outside, so that's up 4. So right 2, up 4, vertical stretch by 3. Now, I did a couple combinations right here. So here, this 4, it's out in front. It's greater than 1. I usually don't like to do the 4 first. I like to go inside or do my translation first, either outside as well. So this is plus 3, which is really left 3. Remember, it's backwards. Left 3. Now, once I've moved it, my center point, my 0, 0, in this case, my y-intercept, left 3, then I do the slope of 4 from that point. Okay, so how it look is like this. Okay, I'm going to go left 3. That's that horizontal translation or shift. Now my slope is 4. So I'm going to go up 4 and over 1. Well, why 4 over 1? Because that's a 4 times my original slope of 1 means my new slope is now 4. And we always go from our starting point. Okay? Then I just connect those dots, and that is the graph of that translation. Well, what about this one, Mr. Hanna? Well, okay, well, let's go ahead and do that one. Again, I like to do the translation first. So I'm going to do the -6 first. Okay? There's my down 6. Why down 6? Because that's a -6. Remember, this is outside. See how it's outside the function compared to the inside? Okay, you need to memorize that. Then there's an in front, but it also has an x-axis reflection. So this has all 3, or just 3 of the 4, I should say, because there could be all 4 in one. That's a stretch of 2. Why a stretch, Mr. Hanna? -2 is less than 1. Remember, it's the absolute value 2. You ignore the negative. So that's really just a 2, which is a vertical stretch. Then the x-axis reflection. Well, you can handle that when you do the slope. So now my slope, instead of being positive 2 over 1, is up 2, left 1. Or if you want to, down 2, right 1. It doesn't matter which way you go. Now you've reflected it over the x-axis when you flipped it instead of going this way. Now, this is why I said I don't like about linears. It looks like you reflected over the y-axis. Well, really what you did from here is this was a slope of 2, right? This end popped up and that end popped down, and then you move down. Okay? But because I like to do the down first, it makes it easier, I think. It looks like you went over the y-axis when actually you went over the x-axis. So, a lot here. Key is to come up with a process of how to think through it. So what I always do is I look at the original function first, and it doesn't matter what the original function is. This could be 2x plus 5. Now, what would that do to change the vertical or horizontal translations? Nothing. It would change the slopes, however. If this had a slope of 2 to start, then this slope would be 3 times 2, or now 6, instead of 3. This slope would have been 4 times 2, 8, instead of 4. This slope would have been -2 times 2, -4, instead of -2. So you do have to watch for that. But as far as the translation is concerned, it doesn't matter what this is. It's just going to move the line up or down, left or right. You really only have to worry about the slope of your original line that you're transforming if you've got a dilation, which is this. These, remember, are called dilations. Vertical stretch, vertical shrink, or a dilation. Okay, then the negative is just there. It's either there or it isn't. Okay, now, watch your combinations. Come up with a way to think through it. So what I always do is I usually start from right to left. I look, is there anything on the outside? Did it move down or up? Then I look on the inside. Did it move left or right? And I handle that first. And I always start with the y-intercept, whatever it is, of the line. I move that point up or down, left or right. Once I have that set in space, then I identify my new slope. And then from there, I just graph the slope. Okay? Now, if you're just describing it, all you have to do here is say, oh, this went down 6, vertical stretch by 2, x-axis reflection, all 3. Now, if it all happened to go left or right as well, then you just mention that. So there's 2 things they're going to do. They're going to ask you to describe the transformation, no graphing required, all right? Or they're going to ask you to describe it and graph, okay? Now, a lot of times with the graphs, especially on tests, STAR tests, ACT, SAT, that kind of thing, if they do that, they're going to usually provide the graphs for you, and you just identify which graph goes with it. But usually with transformations, they prefer you to describe them. So multiple choice, watch for all 3. If you just go through them one at a time and just list them, outside, inside, and in front, these 2, then you're good to go. Hopefully that helped. But again, notice, first you have to understand what's going on. Then you got to memorize your keys. What are you looking at? Okay, what are they giving me? You don't have to make these decisions. These are already given to you. Okay, including the original function. You just have to decide how they transformed that. Did they dilate it? Vertical dilation. Did they vertical translation? Did they horizontal translation? Did they do the x-axis reflection? You just identify if it's there. Anyway, hopefully this helped with transformation of linear functions. If you're still confused on the transformations, I remember I had another video on it with other shapes that may make it easier for you to see, because lines don't really have a set shape, so when they move, it's kind of hard tell where they moved. It's just like another line in space. But remember, you can watch this video multiple times, pause it, take notes, find a way to memorize your keys. All right? Once the keys are memorized, then maybe just practice over and over again until it makes sense. Anyway, this has been Mr. Hanna with What the Format. Thank you very much for watching, and happy mathing.